All right, so this is question number 9, January 2021. This says, in the diagram below, A, B, C, and D are points on the circumference of a circle with center O. BOD are AOC and BOD are diameters of the circle. AB and DC are parallel. So all that they're saying, they just said we can see the diagram from ourselves. Then we are asked to state the reason why angle BAC is 90 degrees. So the examiner is saying to us that ABC is 90 degrees. So that's this angle here. What he's asking us is to state the reason why. All right. And the simple reason for it is that angle ABC is an angle in a semicircle. Now, the angle in a semicircle measures 90 degrees. So ABC is an angle in a semicircle, which, sorry, you can put a full stop, and then you can say an angle in a semicircle measures 90 degrees. Angle in a semicircle measures 90 degrees. Guys, so how do we identify angle in a semicircle? We need to go back and watch those videos on circle theorem. Circle, diameter. The diameter divides the circle into 2 equal halves. A half of a circle is called a semicircle. The perfectionist in me is saying, do it over. So this is my circle. All right. If this is the center of the circle, this is a diameter. So this is a diameter. This is the center. The center of the circle is a straight line that passes through this. The diameter is a straight line that passes through the center, that it divides the circle into 2 equal half, and a half of a circle is a semicircle. Now, if you have an angle that starts at one end of the diameter, go up to the circumference, and then comes back down to the other end of the diameter, that angle, the angle that's formed at the circumference is equal to 90 degrees, and it's called the angle in a semicircle. So it must start at the diameter, one end of the diameter, go up to the circumference, and then come back down, to the other end of the diameter. That angle from circle theorem is equal to 90 degrees because it is an angle in a semicircle. Next, we are asked, determine the value of each of the following angles, show detailed working where necessary, and give a reason to support your answer. We need to find angle BAC. So let's identify it. Angle BAC. Angle BAC. BAC. So that's this angle here, the one that says 2P. That's what we want to find, BAC. So let's see how we're going to find this. Well, remember, we just see that this angle here is 90. So triangle ABC is a right angle triangle, and the angles in a triangle add up to 180 degrees. So it is 2P plus 3P plus 90 that is equal to 180 degrees. So I'm going to go 2P plus 3p plus 90, that is equal to 180 degrees. The reason here that these are the interior angles of a triangle. 5p is equal to 180 minus 90. 5p is equal to 90. Divide both sides by 5, and we get p is equal to 18 degrees. Now angle BAC is equal to 2p, which is 2 times 18. This is 36 degrees. The next thing we're asked to find is we're asked to find angle Q. The next thing we're asked to find is angle Q. So this is angle Q here. Now guys, angle Q is actually equal to whatever 2p is, angle Q is equal to the same thing. So since this is 36, this is also 36. They're called angles in the same segment. I'll try and illustrate why. So here's my circle. A line drawn like that is called a chord. All right. Now I have an angle. It starts here up to from the chord to the circumference, and then back down to the chord. That is the 2p. I have another angle that starts from the same end of the chord up to the circumference, and then back to the other end of the chord. This is Q. Now, whenever a situation like this, these two angles are equal, they are called angles in the same segment. Those two angles are equal, they are called angles in the same segment. So I'm going to say that Q is equal to whatever 2p is equal to, which is what? 36 degrees. And the reason for that is that they are angles in the same segment. All right. Next now, lastly, we're asked to calculate the value of the angle R. All right, we're asked to calculate the value of the angle R. All right, what's the easiest approach I can think to take for this? Now, tell me if you agree with me that the angle at C is an angle in a semicircle. Well, you don't have to tell me. The angle at C is an angle in a semicircle because PB is a diameter and C is formed at the circumference in the circle, and the other two ends of the angle, B and D, are the two ends of the diameter. So the angle at C is an angle in a semicircle. So what that is saying is that, or you know, I didn't even have to do it that way. So let me not do it that way. I have an easier, quicker way. Look here. These two lines are parallel. So look carefully. Tell me if you see it. These are alternate angles. 2P and R are alternate angles. So I'm going to say that R is equal to 2P, which is equal to 36 degrees. They are alternate angles. Your alternate angles are Z angles. Stay with me. This is a bearing question. All right. It's a topic that we need to practice some more. It says from a harbor H, I don't know, I have a problem with that word, harbor. From a harbor H, the bearing of two buoys, S and D are 185 degrees and 311 degrees respectively. Q is 5.4 kilometers from H, and S is 3.5 kilometers from H. All right, we're to on the diagram which shows the sketches of this information, insert the value of the marked angle QHS. We need the value of that angle. It's not difficult actually. What this is saying is that, remember the bearing of Q from H is 311. So bearing is measured clockwise from what? North. So the angle that goes all the way around is 311 degrees. We need the angle in the middle. So from north, come around to the first side of the triangle is 185. From north, going all the way around to the other side of the triangle, it's 300 and what? And 11. It means that the angle in the middle, angle QHS would be equal to 311 minus 185. The angle is 126 degrees. 126 degrees. So we're asked to put in this angle. It's 126. Guys, calculating it is not enough. The examiner specifically asks you to put it in. So you must put in the angle 126. What else? We're to calculate QX, the distance between the two buoys. So now to calculate this, we're going to have to use the cosine rule. Guys, the scenario we have is that we have two sides of a non-right angle triangle and the angle between them. So let's recreate this on the other side. So we have something that looks like this. Something that looks something like that. Yeah. All right, where this is Q, H, and this is S. This is 3.5. This is 5.4. The angle here is 126 degrees, and we're asked to find this side. Ladies, gentlemen, if you know two sides of a non-right angle triangle and the angle between them, and you're asked to find the third side, you must use the cosine rule. The cosine rule formula is a squared is equal to b squared plus c squared minus 2bc cosine a. So in this formula, a is the side opposite the inclusive angle, which is x. So this is x squared. B and c are the other two sides. So this is 3.5 squared plus 5.4 squared minus 2 times 3.5 multiplied by 5.4 times the cosine of 126 degrees. So I put that in. So I'm just going to put all of this in my calculator now and press equal. So we have what, 5.4 square plus 3.5 square minus 2 times 3.5 times 5.4, the cosine of 126. Just put that in my calculator and press equal. And I get 63.6. So this is 63.6. The opposite of square is square root. So x, which is QS, is equal to the square root of 63.6. QS is equal to 7.97. So I'm going to round it up to 8.0 kilometers. All right. Now, lastly, for this question, we're to calculate the bearing of S from Q. All right. So now, in bearing, whenever you're taking bearing, wherever you're taking the bearing from, you're going to go to that point and draw your north, south, east, west line. So that's my north, south, east, west line. I'm taking the bearing from Q because it's the bearing of S from Q. Now, bearing is measured clockwise starting from north. So this is the angle I need. All right. Now, we already have some information down here, so that I didn't put in. All right. All right, so this is another north-south line. All right, not that. All right, so we need this information. Remember the angle coming around from here all the way around here, so is 311 degrees. We know that. All right, now the angle over here is the one we want. Let me change the color ink. This angle here in blue is what we want. Now, what we're going to do is find this angle here, then use cointerior angle to find this part of the angle. Let's call it alpha. And then we need to find this part of the angle. Let's call it beta. All right, first of all, theta is equal to 360 minus 311. So this is equal to what? What is 60 minus 11? 49? 49 degrees. So this is 49. Next, alpha would be equal to 180 minus 49. And this is because they are co-interior angle. So this is 180 minus 49 is 131. So we have the top piece now. Remember, for the bearing, I need both pieces. I need alpha and I need beta. I have alpha, now I just need beta. And as I said, I think I'm going to do it. I'm going to do a workshop on this topic tomorrow. All right, so to get beta now, beta is inside of the triangle. And after you use cosine rule on a triangle, the next thing you must use is the sine rule. So for the sine rule, the sine of beta, because I need beta, over the side opposite to beta, in front of beta is 3.5. So it's over 3.5 is equal to the sine of the other angle, which is 126, over the side that is opposite to 126, which is 8. This is sine rule. 126 over x, which is 8. Bring this 3.5 here. We have sine beta is equal to 3.5 sine 126 over 8. This now is 3.5 sine 126 divide by, let me close the bracket here, divide by 8, and we need 3 decimal places. This is 0.354. If I know the sine of an angle, to find the angle, I must use sine inverse. It means that theta is equal to sine inverse 0.354. Theta is equal to, so shift sine 0.354, close bracket. This is 21 degrees. Now, the bearing of Q from S, the bearing of Q from, sorry, it is of S from Q is equal to alpha, which is 131, plus theta, which is 21. This is 152 degrees.